and but comparing to the hard disk drive, 0 moving part. That's the benefit. Okay. Performance is better, but problem is still expensive. Okay. Right now the 1 terabyte is around the 300. Is the last semester the one. Okay. So this is SSD and the hard disk drive, but mostly we are going to, in terms of the addressing part, there is not much different. That will be discussed in the file system. So we are going to focus on the hard disk drive, the I/O devices. Okay, in this I/O management. Okay, go back to the main slide. So we have seen. So the hard disk drive, not the SSD. SSD does not have the latency, but the hard disk drive still has a latency. So there's a 6 times plus the average rotational latency. So you can see the average. So when we calculate the average I/O time, that has the access time and the other overhead. This one is really happened when 1997. I worked, as I said, I worked for the DBA in the one of bank in Korea. At the time, our department, IT department, was the first the I/O at the IT department who purchased the EMC. Disk storage box. EMC is still one of the biggest company for the storage. They build by combining number of hard disk drive. They sell the disk storage box like the terabyte, not terabyte, is petabyte size level and so on. But 1997 we purchased 72 gigabyte, but the mirroring is 36. Around 30 something the gigabyte, the storage box. It was huge at the time. So then the price was the 3 times of my yearly salary. Only the 36 available because it has the mirroring. Only half of them are used. So when we order to the EMC, so they actually ship like this way really. It's 1997. Then even we asked the policeman because and we ordered the non-vibration. So the truck, delivery truck nowadays is popular for such the sensitive device to deliver, but it was not at the time, 20-30 years ago. Then actually the police car convoy to deliver 36 gigabyte storage box. Then it was the first one. I will show you later the diagram that I used. Anyway, so then that's not the only one. So we have still the magnetic tape. We use this is a kind of, it's not actually the LTO that we are currently using, but the same shape. It's actually same thing. So some of them can keep the 8 gigabyte. Some of them are the 16, the 24 gigabyte. The benefit, cheap. So it's still used for the backup device. So if you purchase or if you have a chance to see the backup, the device, it's like the round table, okay? Like when you take the photo in the amusement park or so on, so you can get into it. It's similar. It's like the round cylinder style. The room, then they test the arm in the middle and a lot of like the 1,000 of the storage of this backup device. And there's a writer, 16 to 32 writer. So get one of the magnetic and push into the writing the device and writing. So still used for the backup device, and it's called the LTO. Okay. Benefit is a cheap. Problem is a sequential reading. So because of that, it's useful. But it's reliable. The magnetic tape is surprisingly very reliable, unless you avoid any magnet. So it's still use the backup device. Okay, then what we are interested in the how to organize, how to use such a I/O devices. So that is the disk structure. Eventually, we will discuss about the file system as a part of the operating system. So, what the operating system interested in such a disk storage is the logical block, because it doesn't matter what kind of the physical architecture, like the SSD. SSD has the same addressing format, LBU. Logical block unit, which means by the divide, you can divide the addressing by the same size of the block, so it can be number 0, block number 0, and so on. So it can be used for the block. That will be eventually blocking that we are going to discuss later. Okay, so this is a logical block. So logical block is nothing but one-dimensional sequence, the array. So 0 to a number of that. So if you know if you would like to write the data, or if you know the block number, you can get the data through the disk controller. You don't have to worry about how the physical data are organized. And such a device is connected to through the attachment. Oh no, not this one. So this is a disk structure. Then by combining number of the disk storage, we have the different types of the attachment. We will see later this one. Here. One is the storage area network. So when we have the storage, so one of the problem of using the disk storage is the speed. So how does the I/O devices are connected in a computer architecture, in terms of computer architecture? How I/O devices are connected to the computer? Through the bus. Okay? Through the bus. Bus is the kind of highway. It's very fast. The highway to transfer, to receive the data. So in case your storage is connected to the bus, then you will get the same benefit to transfer the data. However, your storage is here, then I have internet connect to the computer. Can you get the same speed? The internet speed is much slower than the bus. That is a problem to share the storage. To address that one, there is among the actually the speed among the different controller, which one is the fastest one? Here. 5 channel. Okay. USB 3 is, what is the speed of the USB 3? So theoretically almost not. It's less than the gigabyte. So several hundred gigabyte. And USB 2 is the 50 to 60, 70. I think that's 50. Theoretically the 50 megabyte. But the 5 channel, like if you have the cable TV, so Fios use the 5 channel. Okay. So which means you may not realize the delay of the transfer the high definition or sometimes ultra high definition the video streaming, because it's fast. So I forgot the speed. So 5 channel almost similar as the bus speed. So using the 5 channel, why don't we have the storage box? It's a big storage box and connect to the computer through the 5 channel. So then you can build something network based on the storage that is called the storage area network. The benefit, storage array, this can be shared by number of computer. Then we can set up the network based on the storage. It's the storage oriented network. This is called the SAN. So nowadays most of the system, the IT department, IT infrastructure use the SAN, storage area network architecture. Another approach is the network attached device. Using the network attached device, so it's called the NAS. So which means each storage is considered as the node, computer. So like how the computer communicate each other through the network. You have a router. This router show how to find the location of the using IP address. For example, if we are using the TCP/IP, using IP address, we can find the location of the computer. Similarly, we regard the storage area, storage as a computer. That includes the IP address, for example. So whenever you access the data in the storage, you can use the routing. So at that time, we need a specific device. It's a NAT, NAT. So these two approach, the storage area network and NAT, is the two popular the storage architecture used in the rear of that. So next class, so we will talk about the what we missed part is in case of hard disk one, how to access the data, how to find the data from the different cylinder, different location. That is to call the disk scheduling. We will continue regarding to the disk scheduling. Okay, thank you, and see you on Wednesday.